Okay, so hopefully you might actually remember the point slope formula. You probably didn't use it that much, but it's a really cool formula. Y minus y1 equals m times x minus x sub 1. So it's called the point slope formula because if you have a point, like an ordered pair, and a slope, like this, you can just go ahead and write your equation right like that. So the way that the formula works is you really need to be able to put the like the x value 3 goes in place of the x1. So that's a little different than what we've seen before. We used to, if you plug in a slope intercept form, the x is just x. Here, this is your y1. And then your slope obviously is your slope. So you basically have to plug in for those three things. And when you do that, you're going to have your equation. So this would be y minus, I guess y1 would be negative 6, so that'd be y plus 6 equals m, which is negative 2/3, times x minus 3. That's your equation. So it's the fastest way to write an equation. Now you might be asked to convert the equation in slope intercept form or some other form, but that's actually the equation of the line right there. So if they say, what's the equation of the line? That's it. It's kind of quick. It's kind of a neat formula. In fact, as you get towards calculus, you'll see that in calculus, they use that formula almost exclusively for a line because it's so fast, so easy. So we just plug into the formula. It'd be y minus y sub 1, which is like minus negative 1, which is like plus 1, equals 1/2, which is a slope, times x minus x sub 1, which is 4. And you have your equation. So let's say you wanted to convert this into slope intercept form. So if you want to get it in the form of, the question said, please put your answer in slope intercept form. So you've got to solve it for y, right? So you're going to kind of subtract that 1 over. So you get y equals, let's subtract 1. So y equals 1/2. I'm going to go ahead and distribute here. So 1/2 x minus 1/2 times 4 is minus 2. And then I still have that minus 1 at the end. As you get y equals 1/2 x minus 3. So that's actually equivalent. And so now we know how to graph this. I mean, it is tough if you have to graph something like this. Like, it's not an easy thing to graph. You could plot points, make a table like we've done before, but it's not a great form for graphing, but it's a great form to just say, write the equation. There it is, so fast. So standard form has a couple of things to it. So standard form officially looks like this. It's ax plus by equals c. But there's a couple like things that we're very particular about. So one requirement is that a must be positive. So if a is not positive, I guess you would divide everything by negative and make sure a is positive. A has to be positive. Another thing that has to be true is that A, B, and C all have to be integers. That means no decimals, no fractions. They have to be integers. So if they have a fraction, you might just multiply by the denominator by everything to get everything to be integers there. So they have to be integers. And again, A has to be a positive integer. So let's try to get this in the right form. You notice that the x term is on the left-hand side of the equation. So I'm going to kind of try to get that over to the left-hand side. So I'm going to subtract 2/5 x from both sides. And that cancels. So you get negative 2/5 x plus y equals 4. Well, I'm almost there. I mean, I have the terms in the right order. I have the x and then the y and then the constant. But I don't like that fraction right there. So what could we do to both sides to get rid of that 5 in the denominator? We can multiply everything by 5, right? So if you do that, you're going to distribute. So this will be negative 10/5, which is negative 2x. And then distribute here, so you get plus 5y. Every term has to be multiplied by 5. And distribute, I guess, the last, like to the other side, or we multiply by 5 on the other side, so we get 5 times 4 is 20. We're almost there. The only thing we're not quite there on is a must be positive. Okay, so a is not positive, so I'm going to divide everything by -1. So you divide everything by -1, you get positive 2x minus 5y equals -20. So I changed the sign of everything just by dividing by -1. And that is considered standard form. So your a is 2, your b is -5, and your c is -20. So stop the recording and try it with this one and see how you do. I'm going to help you though, and I'm going to do it. So you're going to get that over to the other side by adding 3/2 x to both sides. So you get 3/2 x plus y equals -5. I need to get rid of that denominator of 2, so I'm going to multiply both sides by 2. So we get 6/2, which is 3x. Distribute over there, so plus 2y equals -10. And because a is positive and everything's integers, that is standard form. So a is 3, b is 2, and c is -10. Parallel and perpendicular lines. So you may know this already. So let's see. These two lines are parallel. And looking back to our slope lesson, it looks like the slope is 1/2. So the slope of this line is 1/2, right? And you can probably tell from here that the slope of this line is also, you go up 1/2, m equals 1/2. And those two lines are parallel. So what that tells you is parallel lines have the same slope. Now, if you were to draw a line that's perpendicular, it's kind of hard to do, but let's try to draw a perpendicular line. So I'm going to try to do that. So I think it would go something like this. I drew it perpendicular. It's actually not bad drawing. I was able to do it that good because, well, it's not perfect, I guess. But that is 90 degrees. And the reason I knew that is because the slope of this line from here to here, the slope is, let's see, it goes up to, but it goes to the left 1, so a -1. So that slope is, so the perpendicular slope, the slope of the original line was 1/2. The perpendicular slope is called you're going to flip it, so now it's going to be 2/1 and negate it. So it's going to be -2 or -2/1. So this is called the opposite reciprocal. So you flip the fraction, so it's 2/1, and then you negate it. You change the sign, so in this case it'd be -2. And so you can visually see that looks pretty close to, I guess, a perpendicular slope there. So let's look at what a problem might look like. Okay, so we want to put this answer in slope-intercept form. So I want to find a line that's parallel to this line. So when I look at this this line, I really only care about this number when I'm looking at that graph right there. What I mean is this. So I know the slope of this new line is 2/5, right? Because I got it from here. I don't really care about this number right here. A lot of students will kind of start, well, that's a line. If you want to kind of like get a picture of what we're doing here, like this is a graph. Okay, so -3, let's see, 2 this. So if I were to just roughly graph this graph, -3, this line looks like this, has a slope of 2/5, roughly looks like this. That's a pretty good, just kind of general graph of that line. So I'm supposed to, just to understand, I want you to understand like what we're doing, not just the procedure. So we have a point, which doesn't look like it's on that line. 1, -1 is right there. And we want to draw or find an equation of the line that's parallel to the red line. The red line is this graph, right? So we're trying to find, I'll just do a blue line, that has a slope. In order to be parallel, it's got to have a slope of 2/5, right? So maybe, roughly go up 2/5. It's going to look something like this, roughly. But I can't tell exactly where it crosses the y-intercept or anything. It's hard to tell. So I've got to find an equation for that line. I know the slope is 2/5. That's nice. It's handy. So it says to use slope-intercept form. So let's try that. So this would be y, slope-intercept form is y equals mx plus b. So using that form, let's plug in what we know. We know the slope is 2/5. And we know x is 1 and y is -1. So -1 and x is 1 plus b. I'm going to solve for b. I really need to find out what b is. So this would be -1 equals 2/5 plus b. Subtract 2/5 from both sides. So I get -1 minus 2/5 equals b. And to get the same denominator there, you're going to have to multiply that first fraction by maybe 5/5. And then I might be able to add up those two fractions. So this would be -5/5 minus 2/5 is -7/5 is equal to b. So now we have our slope. So y equals 2/5 x. And now we have our y-intercept of -7/5, so -7/5. And that would be the equation of that blue line there, right? It was hard to tell that it crossed at -7/5. You wouldn't have probably guessed that. So that's where, plug into the formula will kind of help you out on something like that. Let's change this question just slightly and try one more question today. So let me clone that and bring it down, and clone this one and bring it down. Okay. So we'll try one more question. So I want this time, instead of finding the line that's parallel, let's find the line that's perpendicular. Right, so that's a symbol for perpendicular. So we're going to find that line perpendicular that goes through this point, but perpendicular to this line. So first, let's just find the slope. Perpendicular slope would be what? If the original slope is 2/5, that's what we don't care about that. We just need the original slope is 2/5. You're going to take the opposite reciprocal. So the opposite is -2/5, and then reciprocal is -5/2. So you flip it and change the sign. So now I have slope and y-intercept. I'm going to use didn't specify, let's say it didn't specify. If they didn't specify what form, I'm always going to default to point slope form. So it'd be y minus y1 would be this value, -1, which is y plus 1, equals m, which is -5/2, times x minus x sub 1, which is this value there. So that's like your x sub 1 and y sub 1 in this form. So x minus 1, and I got it. That's the equation of the line. If they said put it in slope-intercept form or standard form, you'd have to kind of multiply things out, figure out what it is, but they just said, what's the equation of the line perpendicular to that one? And you got it.